everyone. This is graph and Secant. The next part of your graphing trig functions lesson. So the general form for this is y equals a cosecant kx. I left out the transformations, shifting, okay, because we're not going to be shifting here, okay, from cosecant and secant. Okay, so a, there's still an a value, as you see, but there is no amplitude here, okay, for a cosecant and secant graph, and I'll highlight that in a little bit, but there's no amplitude, and your period is going to be equal to 2 pi over k. Okay, some things to note before we move on to the graphing of these, okay. Cosecant is the reciprocal of sine, so we're going to use that fact to help us graph, and also secant is the reciprocal of cosine. And also we're going to use that fact to help us graph, okay. So here are the steps to graphing cosecant and secant. We are going to use this fact. The first step is to graph the reciprocal function with all the transformation. Okay, so graph the reciprocal function. So if we want to graph, let's say, y equals cosecant of x, we're going to start off with my sine function. Okay, we're going to first graph y equals sine of x, okay, which is here, right? This is the sine of x that we all know. Just to label some things else, halfway between 0 and 2 pi is pi. Halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. Okay, just to label my x axis. All right, so that's your first step to graph this. Okay, graph the reciprocal function, and then remember at the midline here is your x axis. Okay, that's the middle horizontal line through the sine function. Okay, that's called the midline. Remember that we're eventually going to graph y equals cosecant of x, which is the reciprocal function of sine. So if you think about it, the reciprocal of 0, okay, 0 over 1 equals 0, right? The reciprocal of that is 1 over 0. We just flip it, correct? So it's 1 over 0, which is going to be undefined. Okay, so your midline, wherever your sine function equals 0, there's going to be a vertical asymptote. Vertical asymptote because it's undefined. There is no value here. Okay, so we're going to get our midline, and we're going to draw these vertical asymptotes. Okay, so there's 3 vertical asymptotes in one period. All right, and then at the minimum or maximum point, they are points on the graph. So this is the maximum, so that's a point. This is a maximum, and that's the point. And all we're gonna do with 4, with that as my vertex, we're gonna draw a parabola going towards my vertical asymptotes. Okay, so here is my minimum, and it's going away from that sine function. Okay, it's gonna go away from the sine function, going towards my vertical asymptotes. So in essence, without this, right, without the sine function, that is my cosecant function. Okay, doing the same thing here. I'm going to graph y equals secant of x. The first step is to graph y equals cosine of x, which is this. Okay. At y equals 0. Oh, this is 2. Y equals 0. My midline. I'm gonna graph my vertical asymptotes and put VA. So here, there is my vertical asymptote, and here is also my vertical asymptote. Again, because the reciprocal of 0 is undefined. Okay, and so here's my maximums, and here's my minimum. I'm going to draw a parabola going away from the cosine function and going towards my vertical asymptote. So since this one here only has one side being represented in one period, I'm only going to draw that half of the parabola. Okay? Simple enough. So we're essentially going to do the same thing when there's transformations. Okay, so this is your parent function. Okay, y equals cosecant and y equals secant of x. All right. So next up, I'm going to add in a transformation of 4x. Okay, so we're going to graph y equals cosecant of 4x. So I'm going to start off by graphing y equals sine of 4x. Okay, my amplitude is still 1. My period here is going to be 2 pi over 4, which is 1/2 or pi over 2. Okay, sine. So that's 0. I'm going to make this 1 and this -1. 2 boxes over, go up. 2 boxes over, come back down. 2 boxes over, go to -1. 2 boxes over, go to 1. Right? So this, and I dotted this because it's not a part of the cosecant function. I'm just using the point and using this as a guide to graph. Okay, so here is pi over 2 because this is one period. Halfway between is pi over 4. Halfway between that is pi over 8. So 1 pi over 8, 2 pi over 8, which is pi over 4. This would be 3 pi over 8, and then this would be pi over 2. 4 pi over 8 or pi over 2. Okay, so I graphed y equals sine of 4x. Now, whenever there's a 0, my midline, there's going to be a vertical asymptote, and a vertical asymptote, right? And then here's my maximum. I'm going to draw a parabola that goes away from the sine function towards my vertical asymptote, and I'm done. Okay? So here too, right? I'm going to graph y equals cosine of 2x. So my period is going to be 2 pi over 2, which is pi. I'm going to first start with 0, 1, 2 boxes over at 0, 2 boxes over at -1, 2 boxes over at 1, 2 boxes over at, right? So here is my function, okay? Here is going to be pi. So halfway between that is pi over 2. Halfway between that is pi over 4. So once you get this point, I know that every key point is going to be this units long. So 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and then 4 pi over 4, which is pi. Okay, so that's just an easy way to remember how to label these points. And then from here, my midline, or where cosine equals 0, right? There's my vertical asymptote. And then from the 1 or -1, I'm going to go towards my vertical asymptote. Away from the cosine function, going towards my vertical asymptote. Okay? So that's y equals secant of 2x. Now let's see what happens if there is an A change. Okay? First step is always going to be the same. I'm going to graph the reciprocal function with all the transformations. Okay? So it's 2 cosine. So I'm going to put this as 2. So 2, 3, 4. This as -2. So 0, 2. 2 boxes over at 0. 2 boxes over at -2. 2 boxes over at 0. 2 boxes over at 2. So this graph here represents this function. Okay? Because it will start off at 1 comma or 0 comma 1, but then this 2 will make it go up to 2, right? At 0, it still stay at 0. Okay? And then this point at -1 will go down to -2. And then these 2 points will just mirror these 2 points, right? So wherever there's a 0, I'm going to put in my vertical asymptote. Okay? And then going away, get my vertex of the parabola, going away from the cosine function towards my vertical asymptote. But what is my period? My period here is still 2 pi, right? 2 pi over 1, which is 2 pi, so that's 2 pi. Halfway between that is pi. Halfway between that is pi over 2, so 1 pi over 2, 2 pi over 2. This would be 3 pi over 2, and this would be 4 pi over 2, which is 2 pi. Okay? Let's see this one. Okay? So here, I'm going to make each box equal to 1, or equal to 1, so that's -3. So cosecant is the reciprocal of sine, so I'm going to graph y equals 3 sine of x. Okay? Here is 0. 2 boxes over is 3. 2 boxes over is negative, or 0. 2 boxes over is -3. 2 boxes over is 0. So here is my sine function, right? Wherever my midline, wherever y is 0, is my vertical asymptote. Make sure it's a dotted vertical line. Okay. My vertex here, my vertex here. This vertex goes up, away from the sine function, going towards my vertical asymptote. All right? So it's pretty simple when there's one transformation. Okay. Now let's see what happens if I have all the transformations. Okay. My first step is always the same. I'm going to graph 2 sine of 3 times x minus pi over 2 plus 1. Okay, actually, I'm going to make this pi over 3 just to make my graphing a little simpler. Okay. Okay, so here, if I wanted to graph this, I want to go step by step. First step I'm going to graph is y equals 2 sine of 3x. Okay. So my period here is 2 pi over 3, right? 2 pi over this number. Okay, it's a sine function, so, and my amplitude is 2, right? So that's 2, that's negative 2, the sine function, so 0, comma 0. 2 boxes over, go to 2, 2 boxes over, go to 0, 2 boxes over, go to negative 2, 2 boxes over, go to 0. Oh, I went 1 box over. Okay, so this is y equals 2 sine of 3x. Okay? The next function that I'm going to graph is y equals 2 sine of 3, the whole thing, x minus pi over 3 plus 1. So this minus pi over 3 means that I'm going to move this guy over to the right pi over 3 units. The plus 1 is up 1. Okay? Before I move it pi over 3, let's get my period. This point is 2 pi over 3. So halfway between that is pi over 3, right? 2 pi over 3, halfway is pi over 3. Halfway is pi over 6. So this is 1 pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2. And then 2 pi over, and then, wait, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is 2 pi over 3, right? So now I know that 1, 2, 3, 4 units, 4 boxes is pi over 3, right? I'm going to move to the right pi over 3. So this point here is going to go 4 units to the right and 1 unit up. So it becomes that. Okay. This point here, 1, 2, 3, 4, 1 unit up. This point here, 1, 2, 3, 4, 1 unit up. This point here, 1, 2, 3, 4, 1 unit up. This point here, 1, 2, 3, 4, 1 unit. Notice that my midline, right, moved 1 unit up. Okay. So my asymptotes, when I graph y equals cosecant, that midline point is my asymptote. Okay, there's my asymptote there, there's my asymptote here, and here's my other asymptote, right? Because that's my midline. Okay, it just moved up 1. And then my max and my min creates parabolas going away from the sine function towards my vertical asymptotes. Okay, so that's how you graph this. All right, last graph, last example. I'm going to graph y equals 1/2 cosine of 2x minus pi minus 1. Okay, but the first step is to graph y equals 1/2 cosine of 2x first. Okay, get all the stretching out of the way and then move it. So here, my period is 2 pi over 2, which is pi. Okay, my amplitude is 1/2. So you know what? I'm just going to make this 1/2. Make this 1 unit negative 1/2. Okay. So it's cosine. So I know it's going to start off at 1/2. 2 units over 0. 2 units over negative 1/2. 2 units over 0. 2 units over at 1/2. Right? So this graph here is this function here. Okay, if I wanted to add the minus pi, let's label my period first. That's pi. That's going to be pi over 2. Halfway between that is pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, and then pi, right? So now I know that I have to move this to the right, pi units, and down 1 unit. Okay? Moving it to the right, pi units, that means I'm going to move this point 1, 2, 3, 4, 5, 6, 7, 8 boxes over. And 1 unit down means since 1 unit is 1/2 vertically, it's going to be 2 units, 2 boxes down. Okay, so every point I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So that point became that point. This point, 1, 2, 3, 4, 5, 6, 7, 8, down 2. So since from here, I just went 2 units down 1, 2 units down 1, 2 units up 1, 2 units up 1. I'm going to go 2 units down 1, 2 units down 1, 2 units up 1, 2 units up 1. This is my new function. Okay? And notice that midline right here came right here, right? So that's my asymptote. You have to follow where that midline goes in order to figure out where my vertical asymptotes are. And then the minimum and maximum are vertical or vertex, and then going away from the cosine function towards my vertical asymptotes. Okay, hopefully this helped you learn about graphs of cosecant and secant. I'll see you guys on the next one. Bye.